double 10. So we have been go through our progress for 2 weeks. Did you guys still remember what we taught 2 weeks ago? It's difficult, right? Okay, let's quickly go through the essential concept very quickly. And I need you guys to help me that which parts is new for you. Because actually I forgot either. I forgot it too, actually. Okay, we talk about what is data. And to my opinion, I think data is a records of the world. So there exists a sampling problem. And if we need, we want to have a more comprehensive observation about an event, a person, or a phenomenon, whatever, we need to make sure our observation is sufficient. So that would address the issues of data balance and the data diversity. And so when we deal with the data collection, we need to pay attention to those issues. And also, if we want to observe a specific object, we say a certain relationship among different objects, then we need to make sure we got as much as possible evidence, observations in those things. So we need to deals with the data carefully. We need to pay attention to the data attributes, the attribute type, the characteristic of data distribution, so on and so on. And after that, we talk about we starting from assuming that each of you are a store owner, so we could collect some information, right? We could collect some information. So through those information, what can we do? And I believe that we already introduced about clustering. In Chinese, it should be named as 分群, and which is to find similar groups and separate the similar object apart. So that would this kind of task to deal with this kind of task properly, we need to define what is called similar. So we need to determine a proper similarity function first. I believe we already talked about those things. And maybe we also talk about classification. In Chinese, it is named 分类, not 分群, 分类, 类别. This kind of task is we want, sorry. For this kind of task, We concerns about a specific attribute of an object, and we call that attribute as the class label attribute, which would be, for example, whether the customer would purchase would purchase a product, for example. So the class label would have the value yes or no. Or well, these guys would cheat me. So the class label would be yes or no. Or the class label would be not, maybe not a label. It would be a value. We want to predict the value. For example, how much a customer is willing to pay for this product, for this kind of product. And for all those things, it is also known as kind of prediction task. And for those kind of tasks, uh, we want to extract the rules among the specific class label, or we say class value among, we want to extract the relationship among the specific attribute and other attribute values, the other attribute values. And for this kind of task, when we want to evaluate uh, whether we build up a good predictor, or we build up a good classifier, we need to pay attention to that, whether we train the model properly. It means when we apply, we using different data, then we will get different classifier. And if we change the learning algorithm, we will also get a different model, a different classifier. So in order, when we want to evaluate a build well-trained classifier, we need to use a different data set. And in order to, like when you do the examination, you should not know all the question in advance. So we should avoid to evaluate a model using the training data set. We need to separate them. And this is a technique, we called it, where is it? Yeah, cross validation. So yeah, I think that's a very high concept level here, right? We talk all those things. Is that right? Hello, anybody can remember? Do you still remember what we taught? Clustering and classification. Is that right? Okay, good. So did we talk about association rule and pattern mining? If you have no idea what those terms means, then that imply we did not introduce them yet. Do you guys know what is association rule or pattern mining? association rule pattern mining. No, not yet. Okay, that's what I want to make sure. Uh, where is the progress? Where is the next part we should go into? Okay, then let's start it again from assuming that we are stone owners. Okay, so we can collect data we need. Okay, suppose that we own a retail store, so we could collect the product information, the cookie names, the brand, uh, what made of those cookies, where the cookies being produced in some country, and the last column is the price, for example. So we have some information about the product, and we could also collect um, how much uh, the product being sold. Okay. And this kind of information is different from product information, because this kind of information is it's dynamic. It means for different seasons, different time, uh, the sale volume will change. Okay, and this kind of information usually reflect the market preference, the customer preference in the market. Okay, so it's different from product information. Okay, so when we could also collect customer information, some personalized, personal information, the name, the gender, the birthday, their preference, preferred style, or their uh, favorite or something. We could collect those information as much as possible. But those kind of information, again, it's similar to the product information. It's relatively static. It means most of the time you won't change your gender, and definitely you won't change your birthday, right? It's this kind of information um, is not, it's personal. It's not relevant to, not directly uh, interact, we said, interact with the product property. And customer transaction is the behavior among, is the customer behavior happened to the product. So it's dynamic. It would gradually have new records generated, and some records may out of date. For example, if we concerned only, for example, the most 3 years, the most recent 3 years information. So when we collect those user behavior, we could also record the time step when the behavior happens, and how, and together with the much more details, like how much how many the product, a certain product be taken, and whether or not the this kind of purge behavior happened under a specific promotion activity, something like that. They say the last column is the discount rate, for example. Okay, we could collect all those things. So we have introduced that we could use those data to do clustering and classification. And based on those techniques, we could further develop recommendation techniques. And today we want to introduce the third very common mining task. We call it pattern mining and the association rule. What is pattern mining? It's, for example, we could try to find relevant product. But this time, we have different definition for relevant. What is called a relevant product? We said two products are relevant. What they mean? In clustering, the relevant could be regarded as, for example, there are similar groups, customers would take the product together. We could define that. Yeah. I'm sorry. That, let's clarify this part more specifically. Because it's easily to get confused here. According to when we look at the property, or we say attributes of a customer or a product, we could define how much they are similar to each other. So it's like we could project the data as a point in a high dimensional space where each dimension stands for a specific, or we say corresponding attributes. Okay, so in that high dimensional space, we could using a distance function to define the, how much a product, or we say a data object, is similar to the other data object. This is similar. But when we say relevant, it's how to say it? What I want to say is that here, when we say pattern mining, we are not to look at the distance. We want to know what common property those products have. Common parts. When we're doing the pattern mining, we want to extract the common parts. What is what it means common part? It means, for example, they have similar behavior, but But I want to clarify it. What I want to clarify is that in clustering, the similarity, the similarity means um, the whole, the all attribute values, how much how much it is close among the whole attribute values of one object to the other object. But here, what we ask is given, for example, given the same two data object, what attributes are in common? So we are not look at the whole attribute. We only look at partial parts. For example, if one object has okay, let me just give you the example. Suppose that you invited your sister to a shopping mall and you take 10, you purchased 10 clothes. That's a lot, right? You purchase 10 clothes or a 10 skirt at a time or 10 t-shirts at a time. Let's use t-shirt as an example because girls and boy all take t-shirt. And your sister take 8 t-shirts. Then here the question, what we ask is, do you take some t-shirts in common? And that's easy, right? If we only, that's easy because when we only look at 2 customer, then we just check your purchase list and her purchase list and do a matching. You can get the results. You could easily to find out what product you purchase in common, what t-shirt you purchase in common. So that would be quite easy. The challenge of pattern mining here is that we want to know not only the common behavior among 2 persons, we concern the common behaviors among a group. Among a group. Then you may say, okay, then we just can check the purchase list one by one and we could go through all the purchase list one time, then we could get the results. Yes, but not correct. What do you mean? If you're doing so, you could find, you could answer whether all the customers in this group purchase some t-shirts in common. But pattern mining is we concern not every. What we concern is most. What does it mean most? It means 80% or 70%. We give a threshold. It's like, oh, most of the customers like strawberry. Oh, most of the people like spicy flavor, whatever. So when we concern is the most, that means we cannot using the method which is check the purge list of everyone. You cannot just match it, because here we allow some matching could be lost. So this would be a very challenging problem. Okay, so actually this question, this mining task, pattern mining, is a very classic data mining problem. Very classic data mining problem. To my knowledge, uh, nowadays, this kind of mining task could only be well solved by data mining techniques. Maybe someday it could be solved by, I don't know, maybe neural network. The we're known, maybe we say AI, but actually, I already told you, AI is a very vague term. Actually, it is built upon a lot of techniques, including machine learning, neural network, data mining, uh, crowd techniques, computing crowd, edge computing, information retrieval and database, and pattern recognitions, and image processing. Yeah. Oh, that is all those um, basic. Actually, it's not basic. Each domain, all those terms I just mentioned, is a specific domain in computer science. But that is all those domains contributes to the development of AI world. Okay, and here I want to say is that uh, classification 分类 actually is well solved by neural network, deep learning techniques, and also machine learning techniques. And cluster is somehow, yeah, it could also be solved by neural approach nowadays. Mm, but maybe not that good. But it's also work for some situations. Yeah. But for pattern mining, to my knowledge, um, it could only be well solved by data mining techniques. Yeah. And actually, pattern mining techniques is uh, the most, we cannot say it's the most difficult. Actually, the most difficult, to my point of view, I would say the most difficult problem would be the clustering problem. And the pattern mining is, the challenge of pattern mining is that you need to know what kind of pattern you want to know. You want to extract. You need to draw out. You need to draw a draft of the pattern and left the details, and left the detail, um, to the data. I mean, it is data will tell you what is the details, but you need to draw a draft first. It's like when you buy a house, you need to have a very beginning plan about how you want to decorate your house. But how to make it come true, you should left the detail to a professional designer that could like, oh, I want um, a more casual style uh, for my bedroom. So then a professional designer would suggest a warm, light colors uh, for your bedroom, something like that. That won't use a very strong, dark, and heavy color on your wall of your bedroom. The kind of concept. So if we could find a pattern, what could we do? The pattern means the common behavior, the common property of a group. So if we could get the pattern, we could understand the group better. And based on the common property, we could design some, it will help us to design, for example, a proper promotion strategy for the specific group. So it will help us to do the marketing decision. Let me give you more examples using the retail data. Okay. For example, here, this is the transaction table. The customer and their purchased item. The customer and the purchased item with product quantities and the date. Okay, and for those two tables, what we can do is, for example, the basic one, the most simpler one, is the item set mining pattern. Here we define the pattern as a format of item set. This is what I called as the draft. You need to have a very high concept level. You need to draw the draft, what is called the pattern. Here we define the pattern as an item set. And then what item set, what the item in the item set, you need to left those details to the data. So what we define is, okay, we define pattern as an item set. So pattern mining now is the item set mining. And then we scan the data. We scan the data and we need to define, so what we're interested in. We said the common, most of the product, most of the, let me check. Okay. We want to know most of the customer would purchase what cookies, what items. And here I cut the name of the customer because we don't care who purchased the product. So we remove the columns of customer's name. And we focus only on the purchased item. So here we scan the transaction and to see how many customers purchase a specific items, then we will get that. For example, chocolate cookies and coconut cookies. Chocolate and the coconut. Chocolate and the coconut. Chocolate and the coconut. Chocolate and the coconut. Did you guys could see uh, where I point? 看得到我游标吗? Okay, good. So you see chocolate, coconut, one, and here, chocolate and the coconut, two, here, the third, chocolate and the coconut, and the last, four, chocolate and the coconut. So there are 4 customers purchase chocolate and the coconut together. And in total, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. So it's 4 over 15% customers would purchase chocolate and the coconut cookies at the same time. That's pattern mining. We have peanuts, 曲奇，曲奇饼干英文叫什么？ So whatever. So what we want to figure out is that, yeah, this is the answer we want to find. The common behavior, the common cookies, a group, a customer were purchased together. So this is data analysis. This is mining. And it has no standard answers. So it is not like classification. It cannot be learned. At least from the current techniques, based on the current techniques, it cannot be learned like classification because that says no rules. Just that the data tell you the detail. This is item set mining. Let me give you another form of mining. Here, in item set mining, I don't care about who make the transaction. I just concern the transaction. I don't care who did it. But of course, we could concern who who generate the transaction. For example, here we could see Alice have a purchase. Bob had 2 purchases. The first purchase, his first transaction happens on May 2nd. The second transaction of Bob happened on May 3rd, right? Then Charlie has 2 transactions. Frank has 2, and Irons has 2, and Grace has 3 transactions. At least 3 days, from May 1st to May 3rd. And then we could transform this into, oh, I'm sorry, I didn't. Maybe it's due to the time. Due to the time, okay, let's look at this data in this way. cut. I need to cut it. This one? No. Cut. No. Mm. Where it is? Here. Hmm? Hmm? 不给剪裁，弄得。Hmm? Okay. Bob, Charles, Frankie. Oh. Okay. 1, 2, 1, 2, 3, 4, 5. As I know, there are 5. 1, 2, 3, 4. This. And the last. So here, from the previous table, we could get 5 data records. We have 5 customers have sequential purchasing behavior. What does mean sequential sequential purge behavior? It means I generate the first transaction, and then I have the following transaction too, the second or even the third. So, and now what we concerned is doing okay. Okay. The form here is we want to find sequential pattern. What does mean sequential pattern? It means, okay, one customer, the customer would purchase the first things and then take the second and the third, so far and so on. Like in item set, when the pattern is defined as the item set, the pattern is we concern what product will be purged together at the same time, will be purged at the same time. And sequential, it means we want to know which product will be purged first. And then this purge behavior would involve, would trigger, not involve, would trigger the next purchase of the other product. So when we do the sequential pattern, we concerns one behaviors. The happening of one behaviors would trigger the next behavior. This is the format pattern, the draft. But still, we have no idea what is the detail. The detail is what is the first behavior? What is it? It purchase what product? We have no idea. We just know that, okay, maybe he purchased the first product. And then it will trigger the purchase of another product. But what is that? What is the specific product being purchased? We have no idea. We will left those parts to the data. This is sequential pattern mining. So we could see the Pina and Chi. See, Pina, Chi. Coconut, Pina, Chi. See, Pina. We take Pina first, and take the coconut. Pina 花生是 Pina 吧 ？Let me check. 瞬间突然觉得不太自信。上课上一半，突然觉得不太自信。Pina, yeah, it's Pina. Okay. See, Bob take Pina, and then coconut. Frank take Pina here, and the coconut here. See? Charlie, no. Aaron take, no. Grace, okay, Grace take Pina here. And then in next transaction, it take coconut. So 3/5 customers take Pina first, and then coconut. That's sequential pattern mining. So when we do the sequential pattern mining, it's not 100% customer have in common. So we cannot just do a simple matching one by one. No. We concern the most. What is the most? The most is a given user specified parameter. What do you think? I mean, you could have your own definition about the most. Maybe 80%, maybe 50%, maybe above 25%. It's all fine. You could have your own definitions. It's like you could have your own similarity functions. See? So when we do the data analysis, data mining, and data application, you need to using your brain. It is definitely not that what AI said. No, that's stupid things. If that is what AI said, that means you are not doing data. You are not tackling the data correctly. Okay. And yeah, sequential pattern mining, we could give different weight to your product. So the format of the pattern could change. And actually, this kind of pattern mining has been carried out in marketing. It's called a high utility pattern mining. If you, I think you guys ever saw something like, for example, books, actually Amazon. But in Taiwan, usually I like to use the example from books. Jobs. Let me search about jobs. Mm, let me see. Okay, you could see here. This is a very simple application of pattern mining. You can see here it said people who take this book also take those book. And if you look at only two products, it seems that this kind of task could be done through a very simple statistic approach. It means when I only focus on this single book, I just extract the customer who take this book and do very simple calculations about the other products the customers take. This is the most naive approach to do this. But actually, I would say this is an application of pattern mining. The reason is, let me give you another example, another very relevant example. It's a second, where it is. Oh, it's already 2. Okay, let's take a 10 minutes break, and I will use the break time to find the material I want to show you. Okay, please come back 10 minutes later. Hello. 你讨厌。哎呀 Hello. Please come back. Can you hear me? Am I look at see my screen? Good. Okay, then let's continue. See? Okay, this is a famous person in Taiwan, Cai Kangyou. Okay, we all know that it's情商哈，不知道 EI, yeah, a person with a very high 不对，情商智商是我忘了 whatever a famous person. Yeah. So usually when we take a book, nowadays the bookstore would suggest us other books that we may like, right? But in addition to the common recommendation, usually we could see they would also provide the bundle set with a better price. How they design the bundle set in a very traditional way, it is the promotion designer design the promotion strategy. I mean, it's a human work in very traditional way. But after the data mining technique, the data mining techniques being built, this kind of task could be done through pattern mining. You would know, oh, okay, who customer who take these books. Most of the customer, for example, the most could be 80. Okay, 80% of the customer who bought these books would also willing to pay for this book. Then you could provide a bundle set to make the purge behavior happen together. And this would help us to enhance the 80%, the the percentage of customers' behavior from 80% up to maybe 90%. This is the promotion, why this kind of bundle set works out in marketing. Okay, so this design will depend on data. And this is another bookstore, Kingstone. And we could see, okay, I search the name of the person and it comes out all those information. And then there is no bundle set provided. Okay, I click this book. And you see, there is no bundle set. However, again, we look at the third bookstore, Chenping, East Line. You see, the same book. It provides this bundle set. Not 2 books, is 3 book bundle set. See? So this shows us the different capability of using data analysis in marketing promotion. It is already happening in the industry, in the marketing. This is this is the very practical utility of pattern mining techniques. Okay, and here high utility pattern means that in addition to the very basic form like item set sequence, we could give different weight to the item, and this would help the store owner, the companies to find those to focus on those products that would provide them higher revenue, the higher profit product. Okay, and in addition to the high utility, there are also uncertain. Uncertain means this whether we in transaction data, whether you purchased a certain item, like did you purchase chocolate? The answer is either yes or no. It's definitely happen or not happen, right? But in some situations, it's not, our observation is not a specific value. It's with probability. For that kind of data, we call it uncertain data. It means the record, the observation of these records is with a probability. For those, we call it uncertain. So it also we could also do the mining text on those data set. So it has uncertain item set, uncertain sequence. And I'm interested, I am very interested in consumer psychology. So I also pay attention to discounted pattern mining. It means I'm interested in what kind of discount promotion strategy would burst um, the customer behavior in their shopping. Discounted pattern mining. And also contrast pattern mining. Contrast pattern means it is frequently happen in one group, but not in the other group. We want to find the very different parts among the two group of customer. Like the shopping behaviors happen in teenager, and the shopping behavior among their parents. We want to figure out what is the essential, the most different parts. Then we would apply contrast pattern mining, so far and so on. But this kind of mining task is very useful, but it's not well known, not like not that well known like classification or even clustering. My observation is that most of the people knows classification, and it is the most easy mining task that people could think of, because it's easily to link the classification, the predicted label to the recommendation techniques. But what I want to say is more than that. Some mining task is not the relevance among the mining task and the application is not that clear. But that parts of that parts the mining task usually quite useful because it could extract those knowledges we didn't discover yet, and it cannot be learned through machine learning method or neural network. But that would help us to discover, to figure out uh, the essential, the important factors within a group, within an event. That is pattern mining. And usually, pattern mining is the basic, or we say the first step of association rule. What is association rule? Association rule is that if a group of people who have the behavior X with a very high confidence, they will also have the Y behavior. But please not to let a person have X with a high probability he would also have Y. That means X and Y has high correlation. And X and Y could be an item set. I mean, S could be an item set, Y could be an item set. So X is not a single variable. It's not a single variable. So do Y. Y could be also an item set or a sequence, not just a single variable. So association rule cannot be done by or cannot be replaced, cannot be covered by the correlation calculation. When X is a single variable and Y is a single variable, and you know the exactly X and exactly Y, it would be easily to calculate their correlation. The challenge of association rule mining is that when X, for example, is an item set and you have 10 items, that means S could be, okay, maybe that's too much. Let's use a even more simple example. Suppose that you have 3 items ABC. Then that means X could be A or B or C or AB or AC or BC or ABC. And so do Y. Y could be A or B or C or AB and AC and BC and ABC. And X and Y. So here we have 6 possibility for X. We have 6 possibility for Y. So for this rule, X imply Y, it means we have 36 possibility. Then you may say, oh, it's not difficult, right? I think this number is okay, it's fine. Please think of that. When we only have 3 items, then it would result in 36 different association rule. It's from 3 to 36. What if I have 3,000 product? 3,000 product is so common in our real life. The calculation would burst very quickly. so that you cannot deal with the association rule. You cannot find the association rule through correlation calculation. It would run out of time. You don't have so much computing resource. That's the true challenge of association rule mining. So in addition to deals with this uh, association rule mining, here I want to emphasize that association rule is not equal to the correlation. It has the concept of correlation, but they are different in calculation. The calculations, the search space is quite totally different. Okay. I want to emphasize this part, especially to the students in the statistical department. Don't mix them together. They are different. Yeah, but of course I didn't tell you how to do this in mining. But uh, even from from the target, the problem formulation, I'm telling you that they are different. Usually we say correlation, we already know a specific X and a specific Y. But here we just know X and Y is a format, but the detail could be could contain a lot of variables, different set of variable or different sequence of variable. Yeah. Or even different structured variable. Yes, I'm saying X and Y, association rule could be done in structured data. What is means structured data? It could be done in a social network. So X could be a structured sub connection among a group of people. And this structure could imply another structure connections. This kind of rules could be done in social network, in computer network, in business network, in medicine,分子生物学, something like that. So it's different, okay? But this kind of, no matter it's pattern mining or association rule mining, the reason that most people won't think of this, won't so familiar. Oh, we said this kind of mining task is not that familiar and not that well known. Okay, not that well known as the prediction task or classification task. The reason is that there are reasons. The reason is that to mine the patterns, for different patterns, we would involve different algorithm. You mine item set, you need item set mining algorithm. You define the pattern as sequential, you need sequential pattern mining algorithm. If you deal with uncertain item set, you need uncertain item set mining algorithm. So for different pattern, you need different algorithm. And this is very challenging for most of the people who are not in the data mining domain. It's not like classification. No matter you use a random forest or you use SVM or SVC, or you use ANN or CNN or whatever. it, all those algorithms do the same thing. What is that? Learning the association, learning the rule, the 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 correlation, not correlate, learning the relationship among some attribute with the given class label. All those algorithms designed, developed by people from different specific domain, research domain. The SVM is developed by people who doing the methodology, the mathematics. And random forest is developed by people doing data mining, tree-based approach from computer science. And the DNN, ANN are developed by researchers in neural network. But all those methods are doing the same thing. But of course, that would, even you give the same data set, they may discover the different rules because they have different learning capability. But for pattern mining, it's not. We could design different algorithm for the same purpose. For example, for mining the same item set. So the answer set would be the same, but the execution efficiency would be different. So, for example, for item set mining, the most efficient, the most well-known basic approach is a priori algorithm. If you know that, if you don't know that, that is fine. You will learn it in the subsequent of this course. And the other famous is FP growth, which is also another famous algorithm. Maybe you don't know yet, but that is also fine. And I'm telling you, these two algorithms will find identical results. And FP growth would always outperform a priori. Always, definitely. And this will result in that there is no search space for people from different data domain, from different domain. For example, today a doctor, a hospital doctor, want to analyze their data, they they would discover that the only choice is epic growth. There is no further research. I mean, there are only limited research work they could do. The only research they could do is, so when they apply this algorithm, what they find, what they discovered from their data set. And maybe that would produce one paper. However, if what they did is classification, it could apply different algorithm. And I mean, like SVM, SVC, this random forest decision tree, ANN, CNN, and they could compare all those, the performance of all those methodologies, and also compare the results they discovered. So they would generate maybe more than one paper. And that's easy. So that is a reason why classification is the task of classification is more popular outside the data mining, or more is known by more people, more popular. but that is not mean this is the most useful techniques. Okay. Yeah, I try to promote pattern mining task as much as I can because there are compare. I mean, mm, it's a feeling, when you see most of the student or most of the people come to me and always talk about the classification, 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 classification. It's quite boring. There are already so many people doing classification, so stop that. Let's do something that people less noticed, which is more interesting. If you want to really go into the data field, I would strongly recommend that you should try pattern mining. Okay, that's it. And so far, is that okay? Can you do you guys know the difference among clustering, classification, and the pattern mining? Okay, a brief setting is that classification, to do the classification, you must know the answer set. You must know the answer set. As a standard answer, a correct answer layer exists, which is the class label or class value. And you want to do the prediction using other information to predict the correct answer. That's classification. Clustering is that when you change something, the answer set will change. For example, uh, in your group, I'm a teacher. So if here we do a clustering, I would be the outlier because I'm the only teacher. You are all students. I'm the outlier. But if in my college, I mean, when I stay with maybe Professor Lin Boxing, Professor Wu Xinglong, Professor Chen Zhichang, then I'm not the outlier. What is outlier? Outlier means that the object that is not similar to any of the other objects. So let's outlier detection actually could be done by clustering approach. If you find you do the clustering and you find no matter what kind of techniques you apply, you would always find a space of a certain data object that belong to a cluster with very with few other data points, then that is the outlier. So for clustering, you need to define the similarity function. And when you change a partial data set, the result will change completely. It's possible it will change completely. But for classification, no matter uh, for classification, once you learn the rules, no matter what data you change, the rule should always work out as much as possible. Otherwise, the rule is not a good rule. That means your model failed. And for pattern mining, we draw the draft of what we want, but we do not feel fulfill the detail. We will make the data, scan the data, let the data to fulfill the details. And this is we when we pattern mining, we want to find the common parts of most data object. And you could define what is most by yourself. It's 50, 80, and you could adjust the threshold by yourself. Yeah. And no matter which, I mean, clustering, classification, and the pattern mining could be also used as the best of recommendation. Recommendation is compared to the three category of techniques. Recommendation is more close to the application parts. It's not analysis parts. It's more application parts. But it could be applied. I mean, yeah. So any questions? That is it clear for you? Okay, thank you. Then I would like to remind you that you don't forget to prepare your proposal. And the deadline would be this week, at the end of October. Okay? So it would be 1, 2, 3. I think you have 3 weeks left for your proposal. And we won't have midterm examination. No, we don't have. Okay. Okay, and actually, in addition to the 3 category, there are still a lot of advanced topic in data mining domain, like influence maximization or influence minimization, semi supervised learning. What they mean super semi as super blah 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 blah. Semi supervised. Semi supervised is a mining test that bridge among clustering and classification. So it's health classification and a health clustering. Usually, this kind of technology would be done upon the case where we have a very large volume of data. However, to give a specific class label for all the data is impossible by human beings. So we would apply the concept of cluster to help us to automatically take the label to critical data points, and that would help the training of a classifier, to help the training of the classifier. Yeah, that's that's the basic concept of semi-supervised learning. Actually, classification also known as supervised, and clustering is called non-supervised. So the concept, the technique to bridge the two is called semi. And also other approach that comes from mathematics is matrix factorization. And this kind of technology usually directly, more relevant about clustering. And actually, but here, when we use matrix factorization, it means um, we need to do a data transform. We need to transform the data before we do the mining task, because actually when you do the clustering with the MF techniques, it means you won't directly define the similarity function. Instead, you need to define the similarity function through data representation. So we will do like attribute attribute normalization. Through this way, we implicitly define the similarity function. Mm. And it maybe, yeah, I just want to explain that, but if you don't understand that due to limited background knowledge, then that is fine. I just tell you, I just want to say it because maybe someone who already heard MF, then he would know what I'm saying. But if you don't, that is fine. So very quickly, let's have a very high concept level summaries. No matter what you're doing, clustering, classification, or pattern mining, rules mining, that is all fine. Remember, we always need sufficient data. What is called sufficient? The amount of data should be large. The attribute, the number of attribute should be, you can just only have one or two attributes. We could have more attributes. And the data should be diverse as much as possible. Diverse, it means you could collect, you could observe a data object from uh, various aspects as much as possible. Okay, we want to enlarge. First step, we want to enlarge our observation, and then we need to shrink our observation. The shrink means that we want to stay focused on what we want. So we need to pick up the most important data, eliminate the irrelevant attribute, just focus on those attributes that is logically relevant to our mining task, to our analysis task. So in order to do this part properly, we need to understand the semantics of every attribute. That is important. So this is the parts we we deals with the data. And then when we do the analysis, we need to know the characteristic of the methods we choose. If you have no idea about a method, then that's danger. That could totally garbage in, garbage out. For example, if a method is for clustering, like k-means, somebody use k-means to do the classification. I ever saw that. Then, of course, that's horrible, a disaster, nonsense, you know? And I mean, that would be, yeah, totally a joke. Don't use that method that you don't quite understand. Maybe you don't you don't understand a method very well in very detail, but at least you should know the characteristic of the method. What this method is designed for what purpose, the data with what kind of property. You need to know that before you apply the method. Okay. And the third is when you do the evaluation, try to dig it as deep as much possible. Try to do the analysis more than just look at a number result. Okay, it's 10%. Oh, it's 5%. Oh, it's 90%. What do you mean 90%? 90% is satisfactory? Not necessary. If the random is 99%, right? So do the evaluation properly, not only look at the data, not only look at the number, but also try to analysis, try to explain your evaluation results. If you could explain what has happened, why the results comes out, I mean, the result comes out to follow the logic. You could explain what is happening, why the curve goes up or goes down, why the percentage is at most 80, or why uh, the second method could have a higher percentage. If you could explain those uh, those factors you observe in your evaluation results, then that means you know what is happening, and that is correct. If you can't, you need to try to do that, to learn these parts. Okay. So from the very beginning, collecting data for data pre-processing, analysis, and evaluation, and finally explanation. Do each parts carefully with your brand. Otherwise, it would be high risk, the garbage in and the garbage out. Okay, the very brief concept. If you should be aware, the data mining is a very long process. This is the data engineering. And that is why data scientists, or we say data engineer, is worth to be paid with higher, more higher than general engineering, than a general engineer, like just do the coding. It takes time to train, to have a person to be a good, to train it to be a good data analyzer. It always takes time. It's not that easy. So this course is just a beginning. It's just a beginning. But if you guys are interested in this field, don't hesitate. It's worth it. If you feel it interesting, it definitely worth it. And this part won't that easy be replaced by AI techniques. You don't worry about that. Because AI is trained based on data. Given different data, the AI will be trained totally differently. Okay, yeah, that's the first lecture I want to give to you. Any questions? 基本概念有了吗？同学们有没有听懂？你哪怕后面的东西听不懂啊，你前面的东西基本概念很重要。什么叫后面的东西？后面的东西就是我们接下来的几个礼拜，我会 go into the technique parts. I will go into the technique part, very technical parts in the following weeks. Maybe you could not learn very well in the following content, in the following lectures, but that is fine. But at least you should learn, you should have the concept, learn the concept well for the first lecture. This is the first lecture we just finished. Okay, Ma? Is that okay? Any questions? Okay, let's take 10 minutes break. And you could think of, if you have any question, just to propose it. Let me know. Okay? 休息10分钟。 Hello. Well, we got the guideline on how the proposal should look like. The guideline, let me check. Did we announce that? Let me check. 助教帮我发了吗？诶 Not yet. Okay, not yet. Yeah, we have guideline. It's like let me show you. Okay. I think I forgot to share my screen. Okay. You guys should collect your own, you could find your own data set. You could collect the data set by your own, or you could also find some data set on the website. That is all fine. Or you could find data from different place, and then you aggregate them together. You link them together. I mean, you may some collect partial data by your own self and got one part from A website and the other part from B website, and you aggregate them together. That is all fine. Anyway, but at least your data set should be with at least 1,000 data records. 1,000? 1,000? I'm sorry. I think it should be 10,000. It should be 10,000. This is a wrong number. Sorry. It should be 10,000. And then you need to introduce your data set in the proposal, where it comes from, how many attributes they have. So the semantic of each attributes. Is there structural within the data set? What it means structural. For example, if you got the data through Facebook API, through Facebook API, and maybe you collect the user data, including one's friends list. So there would be, that would in that format. For this kind of data, it would have the format of network. If you use one data point to represent an individual user, then if to the friend list means there exists a friendship among two users, then they would construct a graph, a network data structure. You mean? So you need to introduce whether or not exists the data structure and what is that structure in your data. And maybe you could briefly introduce or do some simple analysis about your data distribution through some statistic, or for example, the mean value, the total number or something. You need to introduce your data set, describe it as much as possible, and maybe also through some data visualization. For example, for if you do the classification, there are 5 different class label for, I mean, the class, 5 different class label value for your class label attributes. Then what is the distribution? You collect 10,000, and then it's equal distribution. I mean, uniform distribution, or it's a biased one. Whether one labels are highly occupied, maybe over 80%. I mean, this will reveal whether exists unbalanced issue in your data set. And so you need to introduce to a very simple analysis in these parts, some statistic values through some visualization. Then you could know your data set. You could know the characteristic of your data set. And then the next step is, for such a data set, what did you want to do? You want to do what kind of analysis? It's clustering, classification, or pattern mining? And why you want to do this? What is your target application? What you expect? What you expected to see in the result before you perform the evaluations, analysis, before you perform the analysis and the evaluation, what you expect? That is the proposal. And of course, within the whole project, I mean, now I introduce the requirement for proposal. But after the proposal, you would really conduct the analysis part. In that part, you need to learn by yourself some analyzed tools. Okay? You could use those, or you could try to build up your own tool. That is also fine. I will teach you guys some specific algorithms in the subsequent lecture. And finally, you need to report what you've done, what data pre-processing you did, what evaluation, what kind of tools you use, the tool, the algorithm you choose, you developed, and what kind of, how you conduct your evaluation, the evaluation setup, and then do the what is the analysis results, and try to explain your analysis result. It's important to explain your results. And that's all the content. So you will include the proposal in your, and modify some part of that in your final reports. That's all about the project this semester. Did I answer your questions? Okay, good. So next question is, let me ask before we go into the next lecture. Let me ask a question. The following lectures would introduce the techniques, a lot of techniques, and focus on the characteristic of the techniques. So we have 3 categories, right? One is clustering, 2 is classification, and the third is pattern mining. Could you guys let me know which parts you are most interested in? Give me your choice. one or two or three? Type it. Third, pattern mining. Only three students give me response. Okay, I got it. So three the most, and then the second and the first. Okay, then will introduce those techniques in this order. Okay. Mhm. Okay, then let's from pattern mining. Okay, the slides I use is from textbook, from our textbook, Introduced to Data Mining, written by Chen and Kummer. Here I would introduce the basic problem definition about item set mining and what is frequent item. So when we deal with this problem, what challenges we may suffer. Okay, and frequent pattern mining, or we say pattern mining, at the very beginning is known as association rule mining. Because in the first paper, the one who proposed address these issues tackle two problems in one research paper. So at the very beginning, it is known as association rule mining. However, in that paper, actually, they deals with this mining task in two major steps. And the first step is pattern mining. And nowadays, following this work, actually, more and more research doing the pattern mining parts. And of course, there are also a group of researchers try to do the research about association rule. But to my knowledge, it's a relatively smaller group. Most of the research interested in the pattern mining parts because pattern mining has more variations. Okay. And this work at the very beginnings is addressed from a scenario that in America, the target market, they have a lot of data like this one. TID means transaction ID, and the records, so each transactions, while product being taken together. Just like nowadays, we go to the checkout counters, they will give us a list. Okay, what product you take, and each one, the price of each product or service, so on and so on. That is the list. And this is the table, is the collection of the list. So here it means there are 5 transactions and items set. This column means the content of each transaction. And the association rule want to discover. So as we just introduced, its association rule is in the form of X imply Y. Association rule follows this form: X imply Y. And X could be an item set containing single or multiple items. And this rule is explained as when the X happen, what is the confidence that Y would also happen? And here I want to emphasize that it implicitly means co-occurrence, but not the causality. It's not the X results in Y. It doesn't mean that. It just means that the two observation X and Y, we observe that X, the happening of X is relative to the has correlation with the happening of Y. But that doesn't mean that X cause Y. Okay? These parts usually be misunderstood. So I want to emphasize, clarify these parts. And the rule says if X happen, we have high confidence Y would also happen. So we have a confidence value. The confidence is high. So how high is recognized as high enough? It could be 100%. It could be 90%. It could be 80%. And here, the percent means is an observation from data. So it's kind of different from probability, but it's also kind of similar to the probability, just like a sampling. Okay, we say the data is an observation of the world. So the observation actually reflect, somehow it could imply the probability. So here it's the association rule. You could see a very similar concept like a conditional probability here. Okay, then let's go back to the example. So from this data set, what we observed that the purge of diaper imply the purge of beer. You may say, what is it, does it make sense? Then let's see where the diaper happened. In the 2, here, 3. Oh, I can use this. See, diaper, 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 diaper. And when diaper happen, beer happen, beer happen, beer happen. 75 confidence. So we could recognize it as a high. Next, see, milk and bread. Okay, milk and bread. Milk and bread. Milk and bread. When milk and bread are taken together, we could see what? Egg and Coke. Hmm? No, egg and Coke didn't happen. So this is 0. The confidence of this rule is 0. See, it's 0. Okay, egg and Coke did not happen, so it's 0. The next, beer and bread. Beer and bread. Beer and bread. When these two happen, milk happen. It's 50. The confidence is 50. So given each rule, we could do the calculation by scanning the database once. But the problem is there could be a huge amount of such rule exist, as I said. When here we have bread, milk, diaper, beer, egg, Coke. We have 6 different items, right? We have 6 different items. So the possible choice of X would be this much. And similarly, the possible choice of Y would be this much. So there could be this much number of association rules. This number could be variable. So in practical, in real world, when we deal with real world, this mining test cannot be done using this approach. I'm saying list the rule and then calculate their confidence one by one is impractical. This method cannot work out. So what can we do? In order to solve the problem and also to find a meaningful rules, we give more constraints on this problem. The first thing is we introduce the concept of frequent. Frequent means that most, it happens, frequently happen. So most customer or most transactions has this events happen or has this item happen. This could help us to ignore the quite less informations, such as the egg. Only one transaction contains X. So if we could ignore the egg, we could reduce the possibility of X and Y from 2 power of 6 to power of 5, right? This is from the calculation aspect. From the scenario aspect is that why we need to care about the behavior of a very few a few customer. There are only one customer is interested in egg. So this is a personal behavior. This is the personal behavior. This behavior won't help the promotion for the whole market. So we could ignore it. And if we recognize that, okay, if we have totally 5 customer here and only two customer are interested in Coke, we could also ignore Coke if we recognize that. Okay, just it's not even go through 50. It's less than 50. So I don't interested in a small group, the behavior of a small group customer. Then we could ignore it. Then in this way, we could also reduce it in the marketing point of view and also in the point of view of computation cost to this way. In other words, here we only focus on bread, milk, diaper, and beer. And that's enough. Because you see, most of customer, more than 50 customer are interested in bread, milk, diaper, oh, and beer, right? So the first concept introduced here is frequent item set. So we have a definition about item set. Item set is, I think you guys all knows what is set. And usually we use the notation following in the standard rules of mathematics. So this is called a set, right? A set. And here we have 3 items. So we call it 3-item set. K item set, the K means the item set contain K items. Okay, and the support is defined as the frequency of the occurrence. It means how many transactions, how many customers have this kind of behaviors. And here we will get, for example, milk, bread, and diaper. Okay. This, okay. Milk, bread, and diaper, we will get, okay, milk. Oh, no. No. Not this one. Again, okay. Milk, bread, and diaper. Milk, bread, and diaper. Milk, bread, diaper. So there are 2/5 customer interested, not interested, I mean saying they have such behaviors. That shows this behavior. And we call this as a count, right? It's an absolute value. It's a count. When we divided it to the database size, then it will become a support. The difference is here we emphasize it's a count. But when we divide it into by the database size, it will be the support. It will be the fraction. So for each item set, no matter it's 1 item set or 2 item set or 3 item set or 4 item set. For each different item set, we could calculate their support. And we use a threshold, we call it support threshold, to eliminate those item set we don't interested in. We call this a minima support. So this slice, this part eliminate the search space of X and Y from a 2, 6 to a quite small number according to the minima support you set. And of course, the higher the minima support, the less the possible of X and Y. And however, if you set this number too high, there could be no X and Y exist. For example, if you set it as 100%, then no such item exists. So that is why I said it's impossible to be done by just match the common behavior of 1 and 2 and the 1 and 2 and 3 and 1 and 2 and 3 and 4. Because if you do in this way, you will find nothing. Usually there will no one item exist, and that he is so important and favored by the whole everyone, by whole group of your customer. Usually it won't happen. But if it happened, then that means that kind of information is not that important. I'm not important, maybe not that important. I'm saying it's not that hard to observe. So for that is so easy to be observed that we are not that interested in. Okay. However, of course, if you set this as a very small number, like you don't set it at all, like 0, then you will take X into account. In that way, you cannot shrink the search space of X and Y. Then there would be possibility, of course, yeah, you cannot reduce the calculation. So in the end, it would depends on how much research sorry. It will depends on how many computation resource you have. And it's possible that after 1 or 2 weeks, you got a code dump. I have this experience. Before I really know the data mining so much. When I'm a junior student in data science, I try to apply the frequent pattern mining in DNA in protein data set, 蛋白质序列 in protein data set. And protein data set usually contains 15 to 20 different symbols. 就是什么 ADG 是 DNA， 就是它会有不同的分子结构，然后不同分子结构用不同的这个英文字母代替。Yeah. Okay. So I try to do a priori mining. I try to do these things, and then I enter. I set up a not too high minima support, and after the enter, I let it run over 1 week, and at the 10th day, 1 week and additional 3 days, my computer gave me code dump as a response. It means it ran out of all my computing resource, ran out of the memory space. So it called dump. Why it called dump? Because it lists too much rules, like those things, too much rules in the memory space. So called dump. Okay, so this is important. when you, when you, sorry, let me have a drink.嗯 OK， 不太对呀、我的喉咙怎么回事？OK， so if you guys try to do your proposal, I mean, when you do your project, and if you do the mining task, I would suggest you to try a support from a higher value. You begin from a higher value to see whether how much patterns you discover, and then gradually lower down it to a lower value. In this way, okay? This is my suggestion. Begin from a higher value, and then according to the observation, your observation, you could gradually reduce the threshold. But if you find that if you give a high value and it still find a lot of item set, it means that maybe it's not high enough. Okay. But I'm saying don't stop. Don't start your mining task. You're trying from a low minima support. Usually it will take a lot of time. And it's also possible that after several days you got a cold dump. That's not a good news. Okay. So then, based on the frequent item set, so we have X and Y. We want to combine them to form the rules. But here, let's see, okay, X and Y. Here, I want to emphasize that, yes, it's here I want to emphasize that, yeah, it's X and Y, and in the rule, what do you mean? Again, let's explain this rule. This rule said that if milk and diaper happen together with a high probability or high confidence, beer will also happen. Milk and diaper occur. Beer occur too. What do you mean? It means if we want to discover this rule, we need, in the transaction here, we need milk and diaper and the beer happening in the same transaction. Right? So as I said, it's kind of the association rule, implicit kind of conditional probability when milk and diaper happen. Milk and diaper, milk and diaper. Okay, we have three transactions contain milk and diaper. And among the three transactions, how many transactions also contain beer? So the confidence of this rule is 2/3. So the association rule is constructed based on frequent item set. The reason we just explained it, right? We introduce the concept of support. Support make us focus on the behaviors of a large group, a sufficiently large group. So the support, how to calculate the support of a rule is not use X, it's not use Y. Instead, it's use X and Y. See? Because we need X and Y happening together in the same transactions. So the support of a rule is defined as X union Y. This is why here what I want to emphasize. This is the support of a rule and divided by the database size. And the confidence is the support divided by the support count divided by the support of X. This part, the confidence, this part imply the conditional probability. I think this part is more easy to understand, right? So that's association rules. And as we have frequent item set through minima support, we could reduce the possibility of X and Y from 2 power of 6 to a relatively small number. Then we could reduce the number of association rules from this much to at least this much, right? So that is why I say frequent pattern mining, or we say pattern mining, is the first step of association rule. Got it? Any questions? So the formal problem formulation is, what is association rule mining? It is given a database. Here, the example is a transaction, but you could generalize it. I mean, it's not necessary transactions. It could be any database, like a document. You could use a document. I mean, this is a transaction table. This is a shopping log. However, you could turn this into a document. DID, TID could become DID, document. The item could be the term, the words. that appear in the document. So no matter what, you could give a database. However, it's in a format of set. The key point here is not transaction. The key point is the term is treated in a format of set. But of course, that if you treat the document in a set, you will lose some information like I like you and you like me. That means different things, right? So if you just treat the document in set, yeah, of course, some information got lost naturally. But it doesn't mean that you cannot do this. You could do this, of course. Just lost is lost. Maybe it will hurt something, but it's not. I mean, it would reduce the quality that you got, but that doesn't mean that you cannot do that. Okay. So you could replace this transaction database to any data uh, you are interested in. Just remember that with frequent item set mining, I'm saying item set mining, it would be a set. Okay, given such a database, we need two numbers. One is the minimum support. The other is minimum confidence. Minimum support is used to reduce the possibility, the search space of X. And minimum confidence is used to reduce the search space of association rules. I did not explain that part yet because it's too much to explain, too earlier to introduce this concept here. However, I would explain why minimum confidence would help to reduce the search space of the rule in the subsequent lecture. Actually, in the late of this lecture. And so we need these two. Given the two, we find all rules that satisfy the criteria. One is the rule has its support larger than minimum support, and its confidence larger than minimum confidence. This is association rule mining. But if you want to do frequent pattern mining, just pattern mining, then you could ignore these parts. Ignore the confidence parts. You just need a set of transaction and one number indicate the minimum support. Here we not find all rules, we find all patterns. Pattern. Okay, it's difficult to write it. Okay. 用触控板写。好。So we could simplify the question. If you just want to find the pattern, you could just stop here. You don't need not necessary to include the confidence in your mining task. Okay, so today we talk about the problem formulation, and next we will tell you through we will introduce the characteristic of this problem, and from this problem, how we design the basic methodology called a priori. We will introduce that part next week. Okay. So at least you guys know how to plan your proposal, right? Any questions? Is that okay? We stop here today? Okay, good. Thank you. Then let's take up here. Yes? Questions? Just type your question, or you want to open your mic, that is also fine. Okay, no question? Then that take up here. Thank you, everybody. Thank you for your participation. Bye bye.